big, large, full room because we're competing with alcoholism downstairs. So if you have a really interesting question in regards to the topic on the slide, go ahead and stop me. We'll try to answer it in the form, ask your question in the form of a quick statement. I'll answer it or expand upon it as a part of the slide. And if your question is good and compelling, then we'll toss you a t-shirt. So we'll need to know your search size. If I say t-shirt, and my entourage down here will get you a shirt. We do have another one. Mr. Betcher, would you stand up and demonstrate the other shirt? So you'll have to potentially make a choice. And if we didn't bring it with us, that's why you're still sitting. I'll make you stand in a second. Actually, I'll make you stand now. So for those, how many people here have listened to Breaking Down Security? I see like, wow, actually there's like 10 hands up. So stand up you two. This is Breaking Down Security's Brian Brake on the left in a very bright yellow shirt who wants to get attacked by bees. And then my colleague and business partner, Brian Betcher. So if you haven't listened to Breaking Down Security, I really recommend you do. Hacker Hurricane is my blog, so you failed that first test question. I unfortunately put this one up there, so I couldn't ask the second question. So malware is, obviously, it evolves. It ever changes. Anybody here was in the Mandiant talk where they talked about the APT 29 stuff? Anybody what was in that? That's really appropriate for this talk too, so it's going to be interesting to see. But clearly you saw by the fact that they had over 1,000 different samples or 1,000 hashes of roughly, well, they basically said 10 different types of malware, 9 of which were similar, and of all that there were 1,000 hashes, right? So malware evolves, and now obviously by design. So we must evolve. Darwin says so, right? Evolve or die. Well, or evolve or get breached anyway, because, you know, if we get breached, we know that means an RGE. How many people here know what an RGE is? Yeah, okay, resume generating event. I say this kiddingly, but I'm actually quite serious. What is the first thing you should do in an actual breach? Update your resume. He gets a shirt. What size? Which one do you want? Medium Krebs. All right, Brian will try to take care of that for you. That is important because I've been involved with several large breaches, and I don't work for an IR firm. I'm the blue team defender and all that. So I had to deal with the Mandiants of the world and whatnot. And it turns out very logical or methodical management suddenly is rational most of the time. That goes out the window when a breach occurs. The irrationality comes. And so really for us IR people, you should really always be prepared for this. We potentially can be scapegoats. So updating your resume, as much as funny, it's actually a pretty serious comment. Obviously there's endless examples of how many people have been laid off and of course a breach. And of course we're here all because we want to catch the bad guys. We all kind of recognize these guys, these characters here. Obviously Ben 10 with Not PowerShell, Carlos with all of his Metasploit foo, former HP colleague of mine, and our host Dave Kennedy as well, and then Kevin, one of the sponsors out here with his pen testing. And apparently I need to update that picture because now he's handing out the Stormtrooper version of his outfit, so I guess he's decided to go from red to white. Maybe because he's expanding out of pen testing, I'm not sure. So what is sandbox analysis? How many people here actually use sandbox in some capacity in what they do? All right, so about half of you. Actually, all of you use it, right? So if you use anything on the internet, you're using a sandbox. Anything VM is a sandbox in certain aspects, right? They're virtual machines. And so we all have used this. How many people have uploaded hashes or payloads to VirusTotal? That's a sandbox. Payload security or Cuckoo sandbox or malware. These are all sandboxes. Just for the most part, you have a piece of malware, you want to basically analyze it very quickly. So this is something from maybe an email or web surfing, or you find an artifact on a box, or you're involved in something like Mandiant was talking about with APT 29. And so you need to be able to upload this stuff and get some sort of information. And you want to get this information fairly rapidly, and you also want it to be somewhat accurate. So you use these cloud-based solutions because I don't have the infrastructure, so I'm just going to upload my payload to one of the many that are there, and I'm going to go ahead and see what the results are. You can also roll your own, right? So you can go download Cuckoo Sandbox and build your own infrastructure. They are built on virtual machines, not hardware bare bones or bare hardware. So you basically are already not looking like the thing that the malwareans potentially wrote their malware for. So you're not exactly mimicking what you have in your production environment, unless of course you're in an ESXi or Xen or whatnot environment. And again, also these cloud solutions are being heavily used in email gateways and next-gen firewalls. Palo Alto has a service add-on. SourceFire has a service add-on. McAfee, Symantec, all these people have add-ons for their email gateways or web proxies, FireEye, for example, etc. All those are considered sandbox-type solutions from my description. And some even do automated reversing, which is a little bit of a slant from the typical analysis. Most analysis are just detonate, see what happened, determine whether or not it's malicious or not, and give you back some information. There are some free solutions. It's hybrid analysis or payload security's 32-bit free solution. How many people here have played with that or use it? Not bad, gives you some information. Malware.com is really well known in this space. So again, all these are free. Komodo, well, it's Komodo, so I'm not sure it should be on here. DeepViz and Threat Expert, VICheck is a Canadian one, and not so much a fan of that one. And then of course we got to consider VirusTotal now, and we'll talk a little bit about that as we get going. And then if you want an update, so I want to give you the link, that's the thing to really pay attention to here, other than this Prezzo will be obviously recorded, as well as it's streaming for those that are there, and for, I guess, Mike Slavic, who gave me the idea of the standing ovation. Shout out to you for giving me that hilarious little bit. But Lenny Zeltser publishes this stuff and keeps it up to date. So I highly recommend for this area that you look at Lenny Zeltzer's information. And I give you a URL there. So I also post these in my slide share. So if you just go hunt for LogMD or malware archaeology, you'll be able to get my Prezzo and PDF. Paid solutions. Payload security, again, the paid version, you can actually see what they don't give you in the free version and potentially will expose in the paid version. So you will have to pay for these as a service. Joe Sandbox, serious overhaul in his stuff in the last couple of years. And so there's a lot of information there. The graphs and whatnot are pretty colorful. Definitely take a look at that. Register for an account. You can't just upload, you have to register. And then last line is a paid service as well. LogMD will be integrating with that in the future. We'll talk about that in a little bit. And it used to be known as Anubis Labs. How many people here have ever heard or played with the Anubis stuff? It's actually, I have a slide shot of it, but they've taken it offline now because they're focusing at the paid service. Binary Guard, again, paid service, but it does detonate on bare metal. That's going to be an important point as we move forward. And ThreatTrack as well is paid. And again, Lenny keeps a nice maintained site, so I really like that. And again, you can roll your own. So how many people here built a Cuckoo sandbox or some semblance of something similar? You think pretty much, and there's actually a good talk to hear about using ESXi and some kit. I didn't attend the talk. But I did tell somebody that I was sitting next to, and I saw his notes. I'm like, hey, you really need to come to my talk. Because you can build your own, but is it really mimicking what the malwareans wrote their stuff to attack? And so you have to really ask yourself a question on that, and you're going to see why maybe that's not a good idea. But Remnux, Lenny Zeltzer's complete environment of DNS and mail and all the services it can mimic, we're talking serious stuff, but again, it is a virtual environment. It isn't actually production. So if the malwareans are at all smart and they really want to do avoidance, probably like the Advanced APT talk where some of their tools they interfered with, this probably won't work too well because they'll know about it, right? And also these are all very time consuming as opposed to trying to get stuff done quickly. Zero Wine for Linux, Buster, Sandbox, and Malhere is another one. And again, Lenny keeps a nice list of this. But you also could build in Rackspace or Amazon or anywhere else. You could build a cloud server with your own configuration or however you want. And again, you can use one of these solutions to do it. So what is manual analysis? Now this is my definition because there has been training here this week, and so that is a form of manual analysis. But my definition personally is the evaluation of malware on a bare bones or bare metal system to exactly mimic what is used in production. No virtual machines, no cloud. But you might build one to mimic the VM environment you have, like ESXi or Zen or Hyper-V or AWS or whatever, right? So there are cases where you will move to VM, but I'm saying only when that is a production environment is. So you want to mimic exactly what you have. And that's the point here, right? The VM stuff, if you're running on bare bones, is not the same thing. Malware will act differently. And then can you do this within an hour? Right? The whole goal here, when I teach malware discovery and basic malware analysis, is rapid change. Right? The Verizon DBIR report showed that you're compromised in minutes and your data starts exfilling in days, which means as blue team defenders, IR people, we have to respond within an hour or within hours. So the goal of everything I teach and everything I talk about is, can you do this quickly in under an hour? And some people are like, yeah, we can't do this in under an hour. Yeah, you can. And we're actually going to talk about how to do that. So again, you detonate the malware, you find the sample however you get it. I was involved with a big Chinese hack in the gaming industry called WinNTI. In some cases, we had to collect the artifacts, place them in the same locations, and then invoke how they got invoked. DLL side loading, things like that, where I just log in with Explorer, it loads the DLL, boom, it's infected. But however you want to detonate that malware, however you can detonate that malware, that's what you're after. You're after to mimic what it is that got the box infected. And you use whatever tools you want. Now, granted, I have a small subset I think people should concentrate on. And again, I have a basic training course of malware discovery and basic analysis, and Tyler Hudak, because again, he got selected to do the advanced malware analysis training this week. Anybody here attend his training? Great stuff. Griff was there. And so him and I always share stuff. You heard he mentioned my stuff in his class, I understand. And so, again, he's the next step of what I teach. So bite me for getting selected, Tyler. I'm gonna get here. I'm gonna get this training in here. You'll see. But treat malware like it's designed, okay? And so you got to think about, well, how did they design this malware? You may not know until you actually do the analysis, but you should take this seriously into account. And most malware is going to be designed to detonate on bare bones or bare metal boxes. Has anybody done any analysis where they drop a piece of malware in a VM and it doesn't run like you think it should? Okay, so a few of you raise your hands, which means, yeah, we've seen this. I've read reports that some malware up to 30% is now auto VM aware. Now, if it's at 30%, that means it's on, obviously, the increase, because it didn't used to do that very often. I had multiple versions of WinNTI where I detonate it in the VM, turn around and do something, turn around and it's all gone. And so the Chinese were very good at saying, you're trying to evaluate me, I am not going to execute. And so really, bare bones. Manual analysis to me means bare bones, whatever tool set, do it within under an hour. So really, what's the difference? The future. So my prediction is cloud and VM-based solutions, the ones I mentioned, the list I gave you, the stuff that Lenny lists out on his website, will need to have bare bones, bare metal options for you to deal with the malware that's specifically designed for those environments. I also think they're going to have to evolve to have or send you to a Zen environment, ESXi, AWS, Hyper-V, whatever, based on what you have. So if you get a piece of malware on a box and you're investigating it, it's on a Hyper-V environment, and let's say you've decided it is an adversary and not just commodity stuff, you will probably have to analyze that in a Hyper-V environment in the future. So I think that is the move of the malwareans to try to reduce your ability to analyze the malware. We're seeing it with commodity stuff already. It's really quite surprising. And again, malware will evolve to detonate only on what it was written for. They will figure out what to write at stuff. They buy all the stuff we do, and they're using all the stuff we do, and they're going to get bypasses for all that. And again, all to avoid everybody's analysis. So, how many people here run an email gateway? Everybody has an email gateway, whether it's Gmail or your own personal stuff. I don't want to raise my hand. I'm afraid who's going to say next. So one of the things about this talk, which was kind of a joke, Betcher and I were saying, well, what are we going to talk at DerbyCon? Oh, I'm going to do that cloud analysis versus manual analysis and show how much better or different the manual to cloud is. And this shows up. So I'm about to disclose a vulnerability with a very large cloud provider, a serious flaw. There's actually 2 now registered defects with the product. And so there you go. We are going to have some fun in picking out a vendor. I am not going to mention the vendor or anything else. You'll have to figure it out for yourself. I don't want to be that much of a douche, but nevertheless, I think it's important because it drives the point home with the presentation and what we are seeing as IR people are more and more. So hey, I got a fax. Typical fish. A fax? Seriously? That's so 90s. I mean, come on. It's 2016. How many people here actually fax anything anymore? Anybody? Oh, wow. Okay, then your people all opened these emails probably. It's an eFax, as you can tell. It was literally just probably a copy and pasted of a real eFax, is my guess. But unfortunately, with the addition of a Word doc. And the important parts to hold on to, just from a time perspective, is the date and time of this. So we happen to have got this one on 8:30. This is very, current. Matter of fact, there was one I literally detonated yesterday before we flew here. Some of that made it into the Prezzo as well because of the information and a new feature. And so at 8:30, at roughly 11:15, these emails started coming in. And again, simple analysis, fast, simple analysis is what I teach people. Griff's been in one of my classes, so he knows, and Brian has, and well, Brake lives in Seattle, so who cares? Ow. And obviously 7-zip, if you haven't ever taken a Word doc and just open it in 7-zip, you're going to see that within the Word doc is a folder called macros. The minute you see this, you now know that this Word doc contains some sort of VB or macro capability. At this point, you can make an assumption with probably 95% accuracy, short of you having some designed Word doc that does this, especially if it's coming outside in, that this doc is malicious just from this one step. And if you open that folder, you can definitely see VBA, which is indicating Visual Basic VB script capability. So boom, I already know that this Word doc is bad just from that one step. Or I can go to the command line. Okay, as a security guy, use the command line. There are some things with GUIs, but most of us it's command line. String it out, and you can see efax. I just strings efax, and then look for macros, or macro, the word macro, and it will come out and give me the macros you can see on the second line and the third line. So now I know just from doing a type command against a Word doc that it has some sort of macro capability in it. Or look for the obvious thing, which most of these things do after you enable macros, is the document open, which you can just type the name of the Word doc, find, document open, bam, there it is. It has the funny non-clear information, but you now know that this thing will auto-run once you select enable macros. I now know this is bad from a command line, simple analysis. There it is. So, Office Mouse Scanner. How many people here are familiar with Office Mouse Scanner? Works pretty well, I would say probably 80-20 rule in regards to analyzing Word docs and RTFs. There's an RTF scan as well. And just running, again, Office Mouse Scanner, as you can see, the /scan, it'll come up there and sometimes give you, this doesn't work as well as the info, but it'll give you a malicious indicator, and if it can, then it clearly knows there's something malicious in here. A lot of times this does not work. That's the reason I put this slide up versus the other one, because the other one generally always works, is use the info option, because it will extract the VB out of the Word doc, create a directory, you can actually go read the VB script, which is generally really obfuscated. You immediately go, what is this? And you know you have something bad. So again, this doesn't take me very long. So in 1 minute or less, I was able to tell you this Word doc was malicious with very basic analysis. Anybody disagree with what I just showed you is malicious? All right, so consensus is definitely bad Word doc. To be certain the file's bad, of course, we're going to detonate this thing in the lab. There's a reason we do that, which is we're going to talk about here in a second. So let's see what Fancy Pants Email Cloud Sandbox says about it. So email comes from the outside, goes through the SMB gateway, gets evaluated by the antivirus and spam engine stuff, and well, yeah. At 8:30, at 12:02, 47 minutes later, another copy comes in, and so now 47 minutes after this initial receipt of this email, we've received multiples as they come in. They're slow to crawl, right? They don't do the 100 at a time attacks anymore because they understand the quantity limitations you can put on gateways. So they're slow crawling every minute, 3, 5 hour, whatever. And boom, there it is. The clearly seen by there, the outbreak filters say, you're good. The interim verdict, negative. The case of spam is negative, and the virus is negative. So right now, all good. It's not spam, it's not outbreak, it's not virus. And of course, you come down here, and the advanced malware analysis comes out and says the verdict is clean. Okay, I just showed you the file's malicious with some very, very simple techniques. And here is a Fancy Pants email gateway telling you it's perfectly clean. I don't think so. So let's look at a couple more. These are, again, another Word doc, another variant. This is the efax document here. Another copy we got a little later. This is showing up at 11:49. And then here's another one, another solution we got there, redelivery document. Again, they all kind of look the same, both saying they're clean. Sorry, these are Vautrac malware distributions. These are as bad gets for commodity malware. Really, an amateur can decide or see that these things are bad. So even AV caught it in the case of the Vautrac sample. You can see here that the AV at some point caught this. I was really quite surprised because we got this, and within an hour, this particular plugin saw that it was bad. This is our AV on the top and the gateway on the bottom showing that it's clean, but the AV saying, yeah, nope, I see it in Outlook, and no, it is not good. And another sample of Vautrac. We see quite a bit of this lately. Vautrac seems to be the replacement to Dridex in regards to the quantity we see this year versus last year. And so, again, perfect failure of a solution. We, generally, initially we were quoted well over $100,000 to implement, is failing us because it is a cloud-based sandbox solution. So even VirusTotal, I upload VirusTotal. Now keep in mind that when you upload a hash to VirusTotal, you will get back the solution that says, hey, I've already seen this, or reanalyze it. I just said, go ahead and show me what you already have. And again, 8 days later, preparing for this Prezzo, I went ahead and saw it's 28 out of 53. And then I uploaded it Saturday, again, just to see what changes, and a few more creeped in at 33. And again, we're within a week. It's only 9/22 now, and bam, even VirusTotal knows this thing's bad beyond belief. And again, VawTrack, you notice that the file names are changed as well. You upload the hash, they've got the same payload going out as a million different versions. Sometimes they append your email domain to it. They randomize the number, they randomize the name, they put a different image in there, like you saw the eFax. Another one would be something else that addresses your defense industry or healthcare or manufacturing, whatever you are. And they just regurgitate these things by the tons. And so sometimes you'll see the data does not match what your upload is, so you do have to pay attention. You uploaded a hash, not the file name. Sometimes that confuses people. So let's see what cloud analysis. So now we know it's bad from a very simple analysis, and we clearly know that the AV caught one of the variants. So at this point, we're wondering what the heck's going on with this email gateway. So what does the cloud say? Payload security reverse.it is the free version, and in here we can see that the actual file did drop. The Word doc did extract an executable. It's too small for you to read, but I'm just circling the fact that the cloud solution, in this case, the free solution, payload security, did catch it. And it shows you that it did find it, and that it was again, Word auto-open document. And so right now, it tells me there's A, executable, and B, it is definitely an auto-run Word doc, just from the simple analysis. And again, a little bit bigger picture, you can see that it's OI809.exe was dropped, and there were some interesting VB macro strings involved with this thing. So you're like, okay, well, I know it's bad. I have a binary now, great. But is that enough? Well, you drill down a little more, go down the screen. The hybrid analysis shows you the WinWord actually was the parent of this process. It dropped the OI809.exe and then executed another one. So now you know it has two instances. As you can see below, DNS request, contacted host, HTTP traffic, not much there. Again, why is that important to us? We'll talk about that in a minute. I also have used in the past to make sure I covered more solutions, some other analysis when I was evaluating these solutions, because the WinNTI stuff, we had a lot of samples, a lot of options of Word docs. We have the actual WinNTI APT, and you get DLLs, you harvest DLLs. Well, some of these sandboxes don't have a good way to upload DLLs. That's an area they are improving in. And so initially when I started uploading a lot of these, they're like, it's not a binary that I can execute, so you're out of luck. Some started putting some ability, if you knew what the flags were, to do run DLL32, blah, 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 the name of the DLL and the flag, but you would have to know what that is to detonate their malware and load it. But some are getting better. Some of them are running scripts, and they run the DLL through a bunch of options, and then they see if they can get it to execute. Reversing Labs is one of the more expensive ones, about $70K a year. They also have a list of known good lookups. If you're looking for a very good list of known good lookups, about $70K a year, you can literally feed it every file. And if it's a Microsoft file or an Adobe file, they have a really good whitelist. So it'll tell you, yeah, that's good, we know what it is. And then you can filter out that these are unknown and potentially drill down on analysis of those. But an expensive solution, I had an interesting time doing it. The console was pretty easy to use. But at $70K a year for just the detonation part, another $70K for the whitelist lookups and or blacklist lookups. I thought that was a bit pricey for this kind of capability. Anubis, no longer around. They've been taken down, but I did have it when I was evaluating these for this particular area, for this talk that I was planning to do before. I went ahead and threw it up here because this is Lastline now. Lastline is now the company that runs took over, or Anubis initially started out. They created a for sale version called Lastline. And then, of course, malware.com. A lot of us have used that. A lot of people are familiar with malware.com. And again, system output there, so you can see that I threw some stuff at it to see what it does. Threat Expert's another one. You can see they're real clear, and this is kind of an important point. Immediately, Russian Federation points out. And this is the kind of stuff as incident responders and blue teamers, we want to see this data and make it more obvious to the person reviewing it. We have a lot of other job duties. We're not full-time at this. We're not full-time malware analysis people. We're not Mandiant. I need to see these things stick out at me, right? It needs to be obvious. And so I rather like the look and feel of this. Joe Sandbox done a lot of work in their whole GUI infrastructure. I really like it. VI check, yeah, not so much. I would just kind of blow by this one. But there's some cloud providers, clearly what Payload showed on that one particular sample, and we're going to take another look at it in a manual way. So we have this cloud stuff, or this sandbox can also be non-cloud. And so what do we really want out of this? Well, I'm an IR guy, I'm a blue team guy. I need the information that allows me to improve my network defenses or figure out if anybody else in the environment has opened this Word doc accidentally, or purposefully, or by design, socially, engineered to open the doc. And I need to know possibly how to clean it. I want to know if I can remediate it, and I know there's two things you can do. You can either clean it or reimage. But I need to know this information, URLs. Okay, if I have a web proxy, I might want to block the stuff. So I need to know what websites were visited. I need to know the IPs, so if I get the IP out of a piece of malware, I can then say, all right, router devices, does anybody else gone to this place? Oh yeah, Bob and Mary and Cody went to this place, so now I know who to go look up or issue a ticket to get visited. File names, if you don't know what the file name is on the box, then how do you know what to look for? Or if it's a random generated file name, how about the directory it's being dropped in? Even if that's random, you can now know the pattern that it's being put in app data, some random name with some random.exe. Well, you can now go to app data and look for some random name and some random exe. So that's an important thing for remediation and cleanup. The auto runs, how does it launch? That's a piece of information I want. I look at malware as a snake. I need to chop the head off the snake. A few pieces of the body stay behind. That's okay. It's not auto running. It's not persisting. And I've got the main binaries. For the most part, I can move on. Not a lot of us can go and reimage 1,000 PCs and 1,000 pieces of malware like we heard the Mandiant project that took, what, 8 months? That's an insane project. They had a lot of work cut out for them there. Of course, the configuration changes. What did it alter? Did it modify the Windows firewall policies? Did it change other registry settings? Did it bork up your Internet Explorer? And all the various things that it potentially can do to the registry, because that's a huge database of all kinds of settings configurations. Like the Mandiant guys pointed out, the RDP got enabled. So can you detect that condition so you can turn it back off, right? You don't want to leave these things open in case someone goes to Starbucks and starts working and poof, someone's trying to RDP into their box because they have a crappy password because they got compromised from Yahoo. So you have to really understand what those settings are. Metadata, these are all the things within the cloud solutions and the analysis solutions that tell you a lot about the file and all the miscellaneous data that's somewhat valuable to help you determine that the file's bad, that it's not, digital signatures, that it's signed or not signed, who signed it, a Chinese company versus, American company, or it's not signed at all, etc. If it's signed by Microsoft, yeah, it's probably okay. Adobe, probably okay, maybe. And so all this information I'm looking for. The behavior, what happened? How did the malware detonate? What was the specific commands or things that it did when it detonated? And then potentially the network info, right? Traffic behavior, net flow. That you're not going to find so much in malware analysis, manual analysis, unless you're going to get into basically the packet capture and sniffing, like something like a Wireshark. I do not have Wireshark and do not use Wireshark for my manual analysis lab. I would do that only after the point I determined a Mandiant type situation where it's a really big deal would occur, and then we'd start getting into it. Because the minute they see that, they're going to kill the malware. We had this experience with the Chinese frequently. We'd install certain tools, boom, they'd shut down. They're very good at this stuff, just like we are trying to become better. So again, what do we want to learn? What do we want from this data? We need to know who else got infected. That is a big thing whenever you look at a piece of malware. What can I get out of this thing that I can execute on a box? And how do I take that information and decide whether Cody is now infected or Break is now infected? What was added? What was changed? Okay. Why? We have to make a decision. Reimage or cleanup? How many people here have a standard reimage for anything infected? Don't even bother trying to clean it up. 1, 2, 3, 4, 5. How many people here really, due to quantities or just workload, or it's the CXO or whatever, have to actually go manually clean stuff up? I think probably a lot of us have been forced to do that. So we have to know both. It's not just one or the other. So it'd be awesome if we could reimage 1,000 PCs, but that's just not reality. So let's see what manual analysis can show us. Well, artifacts and URLs. So in this case, this is a little script that I do during analysis. I run. It's just ipconfig display DNS. I create a little loop that gets rid of all my whitelisted stuff, the stuff that's normal on my malware lab. And we can see here that shoptacky was the particular URL that this Vautrak used, and it happens to be on GoDaddy. We can also see that the Russian Federation was included here. Who is the information, I get the Russian Federation. And so now if I had a web gateway, I have a piece of information that I don't necessarily get out of the sandbox solutions. And of course, in this case, they reached out to Google, and that was, as oddly enough, the APT-29. So maybe this is a very Russian thing to do in using these cloud solutions to either go out and get the payloads and suck them down, or put payloads up if they're stealing data. And so we see this behavior, but that in itself, because it's Google, we really can't block, we really can't act upon it. But in context, which you'll see in a little bit, it's very important to understand what was used in the attack that you can't necessarily get out of the sandbox environment. Okay, the process, the artifacts and what's launched, right? You want to link the processes, the bad exe and what calls what. This is the behavior of the malware. So you understand that that Word doc was launched. Okay, there it is. There's the EFAX. And that the process ID it got, the OX10, then spawned OI 809, which gave now a new process ID, which now can be linked to another version of it. We saw that in the cloud sandbox solution for sure, so we did get that out of it. Clearly not the paths or whatnot. We did get the we did not get the association out of the OI 809.exe to WinHost 32. Okay, so this is something that through doing the manual analysis, I now know I have two files involved. I did not get that out of the payload security analysis that I did. And you can see that it too loaded multiple times. So just from a process execution perspective, I now have two locations, one of which looks like, it's in the Windows system folder, System32, or in this case, syswow 64. And it is named something that looks like a normal Windows file, which could be missed by a typical IT guy. Or a lower-end admin, which is what they're trying to do. They're trying to, obfuscate and get by. And so again, so you have the IP address information. This is the Windows firewall log information, where you get a destination address, the port that it's on, and then the executable. It's the big advantage of the application names of the Windows firewall is it gives you not just IP A talk to IP B, but that the application within IP A talk to IP B, which is real powerful. In this case, we now have a PID showing WinHost 32 is involved. And wait a minute, Win32 host did not show up in the sandbox cloud environment. So we're getting more information manually than we definitely did from a cloud or sandbox environment. And again, what files were involved? We have the files, we have the directory names. Again, doesn't matter what they're named, we have an idea where to look if we need to do cleanup. The file names are definitely going to alter. We heard, again, the manual talking about 1,000 variants of like 9 samples. We see it all the time. We can detonate. We had a Drydex last year. Every time we rebooted the box, not only the folder changed, but the file changed and the hash changed. Every reboot. So it self-propagated a difference every time. You can no longer look for a hash across your entire environment. That's dead. But now we have locations that we can focus on for potential cleanup or further investigation or harvesting. And again, we got something out of manual analysis we did not get out of the cloud sandbox solution. I find this very frequent, by the way. This is the very common thing. It focuses on what's on top once it gets that, but it never sees the bottom part, whether because the malware is intelligent or not. You'd have to reverse it to find out. Persistence is a big one. You got to know the head of the snake, right? What bit you? What's going to reload this thing? Well, the run key updated. Manual analysis can show me that. And that WinHost 32 is the thing that persists. Not OI 809. It loads twice, does the change, and says, okay, I'm now WinHost 32 down here, and go update the persistent auto run key to launch the next time the system's rebooted. I did not get that out of the sandbox analysis either. Sysmon, how many people here have used sysinternal Sysmon tool? Great IR. I would recommend maybe updating your log management solution to collect it. And then if you have to put it on the box, you don't have to update your log management client. You can just start it and then it'll start collecting it. That's a great way to be ready for the use of it. But it gives you a lot more information, Sysmon does. Great for IR. You must use in the lab with the understanding that they can obviously detect that it's there and potentially not work. So be prepared to potentially remove it and try reanalysis. But again, here you can see that OI 809 was directly launching through the Sysmon logs, the WinHost 32, and there is the hash of the file, but also that the files now are the same file, just named differently and put in different places. And so again, malware analysis through the fact that Sysmon gives us file hashes in the logs can show us that information above and beyond what the Windows logs will show us. So another script I run, I look for very commonly parentless processes. So you saw in the sandbox solution of payload, we had WinWord and then OI 809.exe, OI 809.exe, right? Parent, child, child. Well, I always look for these child processes because generally when the droppers install and they trigger something, they're now parentless. That's not uncommon in Windows, but there's not a lot of them in Windows. So I run a script that looks for this condition. Once I find this condition, I then upload that, send them the virus total, and bam, I found a parentless process to focus on regardless of all the other analysis I'm doing. And I now can focus and say, hey, and even VT knows it's bad just from the hash lookups. And so again, I don't get that out of a sandbox or cloud solution, and clearly did not get those out of my email gateway. So let's compare them. URLs, IPs, URLs, yes, I got some out of those in the cloud. They did have a list of like 4 or 5 of them. Whether or not it was from threat intel or not, don't know. But there was 4 or 5 in there. Manual, yes, clearly you saw what actually detonated on our lab. IPs, I did not get any IPs. You saw that from the DNS names on the register and on the payload security. But yes, I clearly have IPs, as you saw from Russian Federation and whatnot in my manual analysis. File names, I got some, OI 809. I did not get WinHost 32 or the context behind that, the location. So potentially I would have missed, if just relying on the payload security cloud sandbox, I would have missed the actual persistence because it did not show up in the eval. And so yes, I do see that in manual analysis if you set the machine up properly. Config changes, I did not see much of that in the cloud solution. Yes, clearly saw that if you again look at how we do it, which we'll talk about. Metadata, there is definitely some metadata, pretty powerful for that scenario. And sign, in fact, whether the malware was signed or not, you can see those, they do definitely look for that. And then behavior. The one thing the sandboxes will not give you, or the cloud analysis will give you, is the behavior, what actually happened. In our case, when we do malware analysis, we see the command lines that executed, we see all the scripts that they're running, we see the actual behavior through process command line. That's an option in Windows. And so we get a lot more behavioral information than cloud will ever provide us. So as you can see, it's a pretty clear winner on the right, that manual analysis is much easier. So again, paid solutions definitely work better than the free ones. Payload's real obvious, they hide some stuff. But again, I don't think it's good enough. I think there's a lot of work to be done here. They are moving towards doing more bare bones, bare metal work because they understand that they're running into this problem. So I know some are working on it. And again, I've loaded a lot of samples to these things, and a lot of them just don't detonate. I have a training class that I show this at, and let the class upload it to the payload, and then I go ahead and detonate it on the lab, and we do the comparison with the chart that you just saw, this chart here. And it's pretty obvious, Cody actually was in that class, that the cloud stuff just doesn't do the same capability that you can do by yourself. And you can do as good a job, and easily, as these cloud solutions do, and quickly too. But they are good for multiple samples. So let's take an example where I have 4 ransomware samples. I don't got time to detonate this thing, because unfortunately ransomware, when it detonates, it encrypts my data of my scripts. So I got to log in as a different user, create a Bob account, log in as Bob, copy my scripts back on the box, and then analyze the logs and everything, boom, 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 figure out what's going on. Well, once I get that data, I get an IP address and whatever, and I know that that's what I'm looking for, and it gives me I can upload the rest of the samples to cloud and see if I'm getting the same info, so I can quickly rip through 3 of them, because ransomware is kind of a pain to analyze from the perspective that all your reports and scripts get encrypted and your output gets encrypted. So it does have some future use for that. Multiple samples of the same thing. If you know what you're looking for, you now can say, yep, cloud's giving me roughly the same thing, or at least enough of what I need. I'll throw these other 3-4 samples of this campaign up there. And so it might have a use there for a lot of people. I actually say that's probably the best use for it. So what do we use for malware analysis, the manual analysis? Well, LogMD, I'm wearing a shirt, I'm wearing a hat, walking advertisement here. The LogM malicious discovery tool was designed specifically for the purpose of quickly analyzing. In working with WinNTI, one of the biggest problems we had is quickly being able to look at these samples that got emailed to us or that we harvested off a machine to get the IP address information, to get the metadata, to get the digital signatures and all the things that we could put into other solutions to say, who else has this? And so we ended up one day at lunch and we wrote it. And so that's how we came up with the idea. And again, when you run the tool, it tells you what's not set on the Windows environment, whether you're actually going in the field and doing this IR on your systems or you're doing a malware analysis lab. And then it won't actually collect the logs until you finish configuring it, and the reports and the dumps tell you what it is. So it gives you the what, how do I check things, and then the what do I set. That's the first purpose of LogMD. It produces an audit report. I'll sample that in a second to show you how you compare to other standards. CIS benchmarks, a lot of us have compliance requirements, so you have to apply that, or USGCBs, think of that as like the STIGs or whatnot. And then if you're, for the foreigners, a lot of people follow the Aussie standards. We have those in there as well. And then whitelist to filter out the known good noise, right? So we know that this stuff's our stuff, or this stuff is normal for our particular environment. I don't want to see that in my results, so let's put it in a whitelist. So we have that ability for you as well. And it produces one big massive report called report.csv, which theoretically you could consume into a log management solution. And here's what the audit report looks like when you print it out on Word. You get the 3 columns of the different CIS stuff, and then you get the WLS and the US GCBs in there. I just took it out to fit it in the screen. And then what your PC looks like. So before you start using the log portion of LogMD, you'll get a report to know what to go set, and then notes about it. And at the bottom of the report, it gives you the actual reg keys to tweak and settings to do. And when you run LogMD and it finally works, you'll get a summary of the output, really cool, so you know if it's got 0 bytes in it, they didn't make any changes to that item. So just looking at the summary will give me information of what the malware might have done. You'll always get process executions, but if you don't see task schedule, something that APT 29 talked about, they used heavily use of the task scheduler. If you don't see any changes in that, then you know they didn't add anything. If there's no firewall policy report, then you know they didn't change anything in the firewall policy. So very quickly you know where not to look, as well as you know where to look by this summary report. Very cool. So the purpose of this is a malware analysis lab. That's what we first developed it for, but it turned out it had a lot of other purposes. Investigate a suspect system. So we have people that bring their system down, we get LogMD to run properly, we reboot the box, the persistent kicks in, it fills the logs, and we can get the data we want to figure out if the box is infected. It's actually how I found somehow a piece of malware that a guy got injected a DLL into Skype, and Skype was the thing talking to this particular bad sinkhole that was triggering our IPSs. And so really quickly, within 15-20 minutes, I was able to determine that. Audit the Windows system for those who are auditors that have to produce reports, like the one I just showed you. You can easily run this and say, hey, go get this fixed. IT or customer, go turn this stuff on. And again, the whole goal here is to help push and move security forward. Blue teamers, as Carlos Perez talked about, the purple team, we need to share this information and help promote us to move forward. If you're going to have any chance of catching the guys that I had at the beginning of the slides, you're going to have to do this to the box so that when they get on the box, when Ben 10 or Kevin or Carlos or Dave or anybody else does their foo, you can actually see what behavior and know where and what they're doing. And so it's designed really to help move security forward in a lot of ways to get those logs turned on. Because how many people here had to deal with the feds? You have any logs? No. Well, I really can't help you much if you can't give me any logs. And I'm an IR guy. I really can't help you much if you don't give me the logs. We're talking immediate jump to forensics, and that's why that project took 8 months instead of 8 weeks. And again, give IR folks in the feds what they need, a tool that really helps you. You can take a full file and registry snapshot, meaning I can take a good box or my particular Windows box, let's say, even if I'm a consultant, snapshot it, because Windows is pretty much the same across all systems for the version, and then compare that snapshot to a suspect system, and I've thrown out all that known good by doing a compare. These are all good, the system I'm trusting, these are the file differences. Now I have a much smaller list, about 75,000 files in Windows 7, 150,000 in Windows 10, yes, double. I can now throw out probably 90% of those files by doing a simple file compare. Registry, same thing. Registry has a lot of changes, so these are going to be a little bigger output, but I don't have to look through the entire registry. A lot of keys never change. Now I can focus at the keys that have changed, that are added, and our reports definitely separate what's been added, changed, and deleted. And so full file, full registry snapshots. Discover tricky malware artifacts. So one of the things we did in WinNTI that I completely stumbled across because of the command line that they executed is they had a key name involved. I investigated the key and I found that there was a 256K blurb at the point, just call it a blurb, in the registry. I'm going, that's really unusual. How many keys have this big a blurb? So it set me out looking for that condition, and sure enough, it was a binary hidden in the registry. So we've integrated in LogMD to be able to scan a system, -RS, to be able to dump out keys that are larger than 20K. You can adjust that any size you want. Once you filter out about a couple dozen keys, a lot of duplicates, your user versus HK users, so duplicates. Once you filter that out, if you were to scan your environment for these large keys, it would stick out like a sore thumb with this particular one feature. Covter does a cool trick. It puts a null byte in the value of a reg key. So when you actually open in regedit or do a reg query, it reads the run key and it throws an error because of this null byte that's in the value. And then when it finally fails, you'll see the other ones that are there, but you won't see the bad one. So now how the heck do I get rid of this thing? Well, Covter had a really cool feature. Well, they knew, like we know, we'll just delete the key and recreate it. Well, no, they recreated it immediately and put the infection right back in. So they were watching the fact that their auto run might be deleted. Awesome. So we did that. We have that as an interesting artifact. So now we look for that null byte being written to the registry as part of a scan. And also the auto runs. We'll be producing reports for auto run stuff as well. So now the run keys will stick out in its own report, so it becomes obvious where that persistence is going to stick. And of course, it was designed for speed. Again, under an hour. Okay. Deploy with anything you want. SCCM, LANDES, manually, walk to a desktop. I don't care how you do it. PS execute, probably not a good idea. PowerShell it. However you want to get this logMD to run on a box, big fix, whatnot, you can do so. Okay, because it's standalone binary, 100% self-sustained. And we also wanted to replace several tools. How many people here have used Redshot? Yeah, you don't need it anymore. It's a GUI. You now have a command line equivalent that's better than Redshot that you can deploy with logMD. So a very popular tool, no longer needed. SHA-1 Deep, SHA-256, we do everything in SHA-256, so you no longer need to run those tools. We look at all the files and do compares, and we'll start scanning and doing reports. They're CSVs. You can totally run scripts and parse this stuff on your own. And so we can get much more data. Say, well, here's this report. I'm going to go ahead and look for all the executables, or I'm going to go through and look at all the scripts and whatnot, pull those out. And so it's really flexible for you guys to come up with whatever you want. And again, replace several older tools. So that's the nice thing. And get rid of the GUI so I can actually deploy these like as I want to do it, or like most people deploy stuff with software distribution or configuration management. And again, do it quickly. Free edition, audit your settings. So you can go download the free edition now. Again, we believe in security getting better. We got to give you the free tools. Okay, it's pretty typical. It's IR people. We don't have something to do the job we want. We go out and write it. Mandiant showed that they didn't have a parser for the index BTR. They went out and wrote it because they have to, because the stuff just doesn't exist. We have to chase the bad guys, and so we end up creating these tools to make our lives a lot easier. Harvest security relevant log data. We don't harvest the entire log. We harvest what we need for an IR or malware analysis purpose. There's a lot of other stuff you're probably going to look at. We're trying to get you to focus of a timeline saying it starts here, roughly ends here, and you can go look to your heart's content anywhere else and for anything else you want. But you'll get a lot of information with the behavior we collect. You can whitelist stuff by IP command line, by IP or by command line, so whatever actually detonated. So if your guys are detonating a script that's normal, you can whitelist that out so it doesn't show up in your results. And the process, also do it by process. Don't recommend doing this very big because you might get rid of sysprep, for example. Oh yeah, we use sysprep, we'll just get rid of it. A lot of known misuses for sysprep, so you want to make sure you get the command line exactly right and only filter that out. Don't go too heavy on the process. And of course, you can do by a baseline. You can do a file as well. You can compare the full system to a baseline. So baseline's a good box. You're comparing to a suspect box, or the malware lab in this case. Same thing with the registry, and the compare with the registry, compare with the full file hash as well, and large reg keys. You get all that for free. It's all yours. Go download it. Let me know what you think. Give us feedback for sure. We do have a professional version, stuff we have to maintain, the intelligence we have to add to it. Does everything the free version does and more. Breakdown, more reports to break down, so auto runs, things like that, PowerShell. And again, this is the second year in a row I've come to Derby saying, I'm going to release which I did last year finally, actually this year, this year, released the Windows PowerShell logging cheat sheet. I'm the guy who writes the Windows logging cheat sheets, by the way. And I held that back for about 6 months because Ben 10 last year did a talk, not PowerShell. Because you can actually launch PowerShell without ever calling PowerShell.exe or PowerShell_IC.exe. I'm like, dang it, now I got to go put how to detect that in the cheat sheet. And so I had to do that and put in there, hey, sysmon will do it because you can see the DLLs are loaded, yada, yada, yada. Well, there's a talk on Sunday I recommend everybody go to, obfuscation of PowerShell, because Daniel works for Mandiant, and he shared with us some information that says, yeah, good luck taking the 4104 events and deciding to run scripts to harvest some of the stuff I have in the cheat sheet, because there's lots of way to obfuscate it. So I highly recommend with the use of PowerShell to go look at that talk, because we are going to have to figure out how to actually hunt the stuff that Daniel's talking about. And so these specialty reports require effort, and that's what the pro version's for. We do harvest sysmon logs. We've got additional API calls. We've got approval to do Google VirusTotal. Also, we're going to integrate last lines. You have to pay for these services, but Google's free for 4 lookups a minute. whatnot, and there's others we're talking to as well. Windows logging service, anybody familiar with the Windows logging service, the project the government made? It's a syslog replacement, universal forwarder replacement. Does all the stuff that sysmon does and more. It logs WMI calls, lots of cool stuff. And so we can collect that agent running locally before you send it to the log server and gain that really cool details. Whitelist registry, compare results, compare the master digest. A master digest, so you got a baseline of a gold build, but now I got a bunch of people that have different apps. I add that to a master digest and I compare the two and it throws those out. So every time you find something new and unique and you decide it's approved, you can throw that in a master digest, a way to get rid of more stuff. And you get free updates and a nice manual that we wrote. So again, future versions, we have PowerShell details coming, VirusTotal, I covered most of this, parentless process and parent-child tree will be coming out in the future. So you saw how I did it in the spreadsheet, kind of, again, the way Microsoft wrote it. We're going to do a little better job and try to make it easier for you to find those links. So as stuff works, because those little hex codes actually are temporary. They can be reused within 5 minutes or less once a process terminates. So you can't say, oh, well, all these are linked. No, at some point, if this stopped, those are something totally different. So we'll set those up in the future as well. And again, VirusTotal, so you can actually then send the results. Again, not automatic, because we understand the closed lab environment. It'll be an option in the command line. You'll harvest the files, put them in a folder, and we'll send all those up at a 4-minute rate. And then some other security vendors we can't talk about right now. But we would like to announce a new feature. So this will be coming out very shortly right after DerbyCon. For those of you that are in the pro scenario, and this guy being one of them, we have integrated the whois lookups. So now the Windows firewall log or sysmon firewall or sysmon network information, there's the IP addresses. You now can see who the owner and network is, as well as the country of origin, and also the network range. So if you do decide to go and block, you now have everything you need. And if you look at this particular output here, probably, I don't know how readable is this? A little fuzzy because of the size, but you can download it and get more detail when you read it personally offline. You can kind of look at this just from the output alone with the whois information and know you've got something funky, because Google's in here, and you can see here the person we called, so you can see who it was, Aaron or APNIC or whatnot. But you can see very quickly that, hey, I executed this thing at this time period, and hey, it went and made a call to Google. I didn't launch anything at Google. Chrome didn't update. Hey, it went to Amazon. It went to GoDaddy. It went to Russia. So you very quickly, just from looking at the country data and the owner data, can really kind of get an idea of what the communication's occurring very quickly, something you cannot get out of sandbox analysis. Okay, and this happens to be the output from Vautrak that I detonated yesterday morning. Okay, so thank you for sending me new malware, Mr. Malwareans, to get a nice little update to the Prezzo. So what do you get with all this? Manual analysis gives you what process executed, where it executed from, who else opened the malware is what you're after. So you take that IP address information, you put it in your Splunk or whatever you have, even if they do it manually, and you say who else got this, the URLs, whatever you're harvesting out of this. And the details potentially remediate or improve your active defense. And I did those spreadsheets in 15 minutes. So you can't tell me you can't do this in under an hour. I can do this better and faster with LogMD than cloud analysis can give me, and I'm on actual native hardware of whatever I'm running it in, whether it's AWS, whether it's Zen, whether it's bare bones desktop, Windows 7, 10, whatever. I can do it much quicker, and I get much better accurate information. So very cool from that perspective. Here's where you can find us, logmd.com. Go download the free version. Malware Archaeology is where you get the Windows logging cheat sheets. There's 5 of them. We have a Windows file auditing cheat sheet, registry auditing cheat sheet, PowerShell auditing cheat sheet, and Splunk logging cheat sheet as well. And again, we have some links to some malware reports if you want to practice what I call malware management. Read the reports of like the AP29, look for those key indicators that are interesting, and say, how do I detect those? Malware management's actually how Brian and I will improve LogMD. We'll take talks like Mandiant's, take these reports, hey, that's really cool. We could search a registry for a URL and find the COM objects going out and downloading the payload and dropping it to disk. We can do that because we have the data, we just have to write the code to do it. And so that's how we improve the product. It was with all these talks and these reports, and we call that malware management. And again, I'll be posting this on SlideShare, so just look for this item. And with that, we have 10 minutes. I'm the only one holding you back from dinner and beer. So, well, okay, I've got my beer. You guys are out of luck. But questions? Great question. What size shirt what shirt are you? Large. Krebs or find your back doors for the feds knocking them. Okay, large back door. Took you a minute. Took you a minute. That's why we had you stand up and do all that. I do not preload this on the system. Why? Because I don't want the malwareans doing an inventory of it. Not that I have an active actor in my environment, but maybe I could. But the reality is I don't leave this stuff on the tool. I use software distribution. Remember I mentioned Landes, SSCM, BigFix, whatever. I am a huge proponent of BigFix. We got any BigFix users in the house that'll admit it? For not patch, or using it for not patch management. Okay, so you understand the whole analysis and fix thing. Is this not the best security tool ever? Yeah, you don't need Mir. BigFix is the boss in regards to tools. Unfortunately, it's owned by IBM. So I push it out with BigFix. So I'd make a fixlet, drop it in there, run the script. I'd tell, we have a -O in the pro version, so you can send the output share, so map a server share, push the output, pull down any whitelists we need, whatever we need to configuration, and then push the output to the server, and then disconnect the share, and then delete the file off the box. So what Mandiant complained about is as they were rolling out Mir, they would not work, right? The Mir thing, they couldn't get it rolled out in time, but a lot of what happens to them, because it's so well known, is the bad guys will stop doing what they're doing because they see Mir being deployed. So no, I don't load this stuff on boxes. We do it with BigFix. Again, in the Mandiant talk, they pointed out how they had to morph how they do things and use the customer's own tools. My top 10 list is this. Log management. I don't care what you used. Hopefully it's good. He understands because we went through 2 of them. Number 2 would be a BigFix type tool. If you want to use Tanium, you're going to have a lot of PowerShell scripts or VB detonating in your environment, so you'll have to figure out how to filter those out. Number 3 is LogMD. 4 through 10 are blank, and now you're getting into the high-end solutions like a CrowdStrike or a Cylance or whatever, because the bad guys are hunting for this stuff 11 on. They really can't do much about the stuff that's 1, 2, and 3 because it doesn't live in the box. Sysinternals, you install it, they look for the reg key, they ran into that with their engagement. So great question, the answer is no. I deploy with my software distribution tool, PSExec, PowerShell, however you want to do it. Don't leave this stuff on the box for them to learn. Yeah? So I want to make sure I repeat the question so that people watching later can get it. So how many times do we see large websites getting malware? Oh, how much do we see delivering through ads? A lot of drive-bys. We've had a lot of, actually it looks like it's morphing from Flash Player, a bogus Flash Player, probably delivered through an ad or just a scripted site on a blog. Unfortunately, like 90% of malware comes from legitimate sites through compromised blogs, whatnot. Adware, definitely. We have given people that are repeat offenders ad blockers, and problem has disappeared for them. Disappeared is a relative term because that means permanency, because of course it's not permanency. So surprisingly a lot. So web proxy with some sort of intelligent of known bad sites, definitely a good thing to have. Would be in my 13th spot or so. Because unfortunately they morph URL so fast it's really hard, but you have the ability now to block it once you find it through malware analysis. That's kind of the reason a web proxy is important. So I do see it pretty heavily. Brian, I think you'd probably agree, we see it weekly. More so the Word docs by far. The Word docs coming through are and again, I won't pick on the vendor other than picking on the vendor like I showed you. Some of you clearly know who the vendor is by the slides, but that's an epic fail. I mean, there are now 2 defects. One, the files are getting released to from quarantine before they're analyzed completely, and the other is the fact they're saying they're clean and they're obviously freaking bad. And this solution's $100 grand plus, and if you're really big, yeah, that's a chunk of money to throw for total failure. Yes, we see it a lot, but mostly the Word docs, the emails by far are, people are click happy. My malware archaeology shirt on the back says because people click on stuff. By far is number 1. Another question. What size shirt? Extra large. Which one you want? Which one? Backdoor in? Backdoor extra large. He's got another large. He's got an extra large backdoor. Good pickup. Yes, blue shirt first, green shirt second. We happen to have some stuff in AWS, so if I had to investigate AWS, I would use LogMD, get the stuff configured the way I want, and harvest the registry and file system and all that. That's how I would do it. I've not tried any of those other tools within the environments. Docker, for example, has a really cool feature where you can actually see the difference of files. This is really good for Linux, by the way, a really great tip, where I can see the difference of the files compared to the actual original snapshot. That's a really cool feature of this whole Dockerized, containerized stuff. And so that, if you can get that ability, it'd be even better if you get the registry. But that's kind of cool for those container scenarios. But I've not played with them. I pretty much, I use something that I know the bad guys really can't manipulate, and that's built into the system. What size shirt? XL. Krebs or backdoor? He's got an extra large backdoor. Green shirt. How do I use the output to further my active defense? Really good question. So actually one of our clients had inquired because of slow links and other things that can you consume the CSV into Splunk? It is one of the reasons we designed it to be a CSV. Excel with the filtering and sorting is an awesome tool. By far the #1 security tool is Excel. But yeah, the use of doing that. So you've got a log management solution, we have a CSV for you to suck in there. So you could actually use that as your forwarder, sort of, so to speak. And so from that aspect, there's that. The other is the IP addresses. So we, in our Splunk environment, when we analyze the malware, which is why we harvest it so often, which is why we're so interested in the cloud email solution, I have Splunk alerts that kind of alert me to the condition that something was clean and now it's malware, and we go get a copy of it, and we analyze it. We put the IPs into the Splunk thing and say, who else opened this? And now we have full coverage across the environment because our router logs are all in, the firewall logs are all in the Splunk environment. So from that aspect, again, web proxy, if I get URLs, I can put those in web proxy and decide whether to block them or set up a report to monitor them. Warning on blocking, when they know you know, danger, if it's somebody coming after you, be careful there, okay? It's better to watch than poke the bear. And the Chinese, when we whacked them, they morphed to the point where, real quick, they came in from Asia-Pac. We blocked all of Asia-Pac to enterprise. They came in from OpenDNS. They changed their malware so it used OpenDNS. We blocked OpenDNS. They changed their malware to use Google DNS. We blocked Google DNS. We weren't using any of them. We did that. They changed their code again to code.google.com. Crap, can't block that. They weren't using a project. They had a 40-character string in the front of the page, and they used 20 of it to tell the malware where the IP was. Brilliant. Okay, so if you start blocking this stuff, you're going to change their behavior, and it's going to become harder for you to react, much like the man you guys were talking about. So monitoring is how I would go after it. Only use blocking when something really bad's occurring, because they know you know, and they'll change their behavior. So again, you have to make that decision based on business and all that stuff, but that's my take on it. So I do that, so URLs, IPs. For those that are BigFix users, they'll totally understand. I have a analysis in BigFix that says, show me anything that's new, and it's called folders of folders. So if you can follow, app data is a folder, but I want to know what's in a folder below app data. So of folders, app data, show me any binary DLL, EXE that's been there in the last that got dropped in the last 24 hours. So now when a malware, I don't care what the directory name gets dropped, I'll see this new funky directory name show up in my analysis alert, and I'll see the new funky binary, and it'll go across all the nodes that have BigFix on it. So I can take that information from basic analysis and create an inventory for SSCM, or I can create an analysis in BigFix or equivalent, and I can then go out and look for that kind of behavior in the environment through those tools. So great question. And if you have NetFlow stuff, you could obviously do the NetFlow details as well. Maybe load Wireshark and do packet capture. Really good question. Yes? As little as possible, yeah. Don't upload the hash of virus total, not the payload, yeah. Correct. Correct. So do you want to know, do you want to upload, the question was, do you not want to upload stuff to VirusTotal? The answer is yes, eventually you do. You want to make sure in any engagement like again, the many guy had mentioned they had to keep everything on a spreadsheet and not on the computer because they were watching what they were doing. And so every time they would write something or enter it somewhere, these guys would see what they entered, keystroke logging, however they're doing it, and then they would morph. They come back after the weekend and they realize all of a sudden, 8 of the 9 things they were watching disappeared. And so you have to understand that, right? Once you get your analysis down, you say, okay, I kind of got what this thing's doing. I'm going to go ahead and upload the payload to VirusTotal. Go for it. but make sure you kind of have an idea of what it's done. Like all the WinNTI stuff that we had, and I got some serious amount of WinNTI, never uploaded it until we finished all the reports and got the debrief to the feds, and then we uploaded it, because the minute that occurs with those Chinese campaigns or Russian campaigns like APT29, they will completely change from doing simple side loading to hiding things in a registry. And now what you were looking for is completely different when they come back in, which is, you know, bummer. You've now upped the complexity. But yes, you do want to do it because that metadata is very valuable to everybody who's using it. But make sure you're done with it before you upload it, the actual file itself. So great question, or the URL or anything else, because they're paying for the service to monitor, looking for that hash, and the minute it shows up in the repo, they know you know whoever you are, and if it's unique to you, yeah, they know you right there know that they're there, not the company itself. So great question. What size? Large? Backdoor? Krebs. Who's got a large Krebs? The other guy. Green shirt. Oh, what size shirt? Big as you got. 2XL. Krebs or backdoor? He's got a double large backdoor. Man. Great. Another question. Yep. I think that guy gets 2 shirts. What size are you? What do you have to enable other than Windows default? Windows default, everybody ready for this? Windows default collects one thing that's useful. One, maybe 2. Service starting or stopping, 7040 event, and new service install, 7045, and login success, local. That's it. And I am not kidding you when I say that's it. So the Windows logging cheat sheet is the thing you want to follow to turn on all of it. Those were designed specifically, the best example I can give you is Nanyan Talk, but we designed them based on the Chinese attacks, WinNTI. Okay, what did we have to turn on to catch all this behavior? And that's actually why I wrote the cheat sheets, because I used to work for HP and teach people this, but there was never really a good resource for it, which is why the cheat sheets got invented. And so that's what you have to do. Literally everything. The PowerShell logging's not there. There is no WMI logging unless you use Windows Logging Service, the WLS stuff. And PowerShell logging's only gotten better in 4 and 5. And you have to use a profile for 2 and 3, and that can be bypassed as they always do, a no profile. Process creation is not on by default, but the CIS benchmark did add that. It didn't used to be in there. And then the process command line is not in any of them. And it only adds 1 line to the 4688 event, which tells you exactly what was typed at the command line. That is huge. And when we're talking to Daniel on Sunday, if you go to the noon talk on Sunday, really recommend you do. PowerShell is going to own all of you at some point. You really need to understand what can happen with PowerShell, and your Linux too, which is even more awesome. That command line execution, the fact of how he initially gets on the box is how you're going to detect that, because he's going to go dark after that. Carlos has a Metasploit module that specifically looks at the stuff we tell you to turn on to determine how noisy he can be on the box. So it is a give, the red team looks what we do and we look what they do, and it's just constant back and forth. So by default, Windows sucks at logging. You must go and enable what you need. You will not catch squat unless you do what the Windows logging cheat sheet tells you. Burst behind there, because he asked. You get his shirt size? Yeah. I'll leave that joke alone. Question behind. Correct. Time stopping. Good catch. Again, we're looking at the window event log time, not the timestamp. I really don't give a crap about the timestamp. It is a artifact to me. I'm looking at the log entry of when the event started and when it ended, and then the times can be all over the place. Yeah, but that file says it's been there since 2005. Yeah, probably not. Go look at the create time, go look at the access time, go look at the write time. They usually mess that up, and they're not like they're supposed to be. And so I generally don't use that feature. That's more of a forensics feature. It's not a quick feature. The log entry recursion is what I'm after. So good question. Shirt size? Extra large. Krebs. Krebs XL. Yes. Yep. Anybody here in the gaming industry, like I was? The most cynical users I have ever had in the gaming industry, without a doubt. I mean, if we ran a big fix inventory on software analysis, because it literally reads every executable to figure out what it is, it's ridiculously burdensome. The logging that occurs for what we recommend in the Windows logging cheat sheet, for example, process create will also create a 4688, creates a 4689. I tell people don't bother collecting that. I know something started, I can go look to see if it terminated, right? It's not a big deal. And so there are ways to trim that data so it doesn't have as much impact. So from that aspect, non-noticeable in almost all environments. There will be exceptions to that because we're talking about modern hardware, not an undersized VM or old hardware. But modern hardware, if it's an SSD, yeah, no problem. Even spindle drives, the gamers never knew. We had every workstation with all the logging I'm talking about turned on every server, every workstation, every Linux box. No one ever noticed anything, and we had everything we needed. But there are older hardware that if something goes abort. Matter of fact, the only notice they would have is when the Splunk Universal Forwarder went crazy. It would be the only real notice. And that's more of a bug in their client software. My son, Ben 10, my internet son. Take questions outside. Thanks.